Okay, doing a few more trapezoid problems. We have the distance from A to B is equal to 14, the distance from C to D is equal to 26, and the distance from A to D is equal to 10. And we want to find the length of the altitude. The length of the altitude is the length of this segment right here. It has to be drawn from any point on one base perpendicular to the line containing the opposite base. So to continue, we're going to draw another altitude, this one starting at point B and being drawn perpendicular to segment CD. So therefore, inside the trapezoid, we now have a rectangle. So if the top side of that rectangle is 14, the segment at the bottom is also equal to 14. If we're looking for x, which is the length of one altitude, it's the same on the opposite side of that rectangle. And if the entire length of segment CD is 26 and part of it, the segment between the two altitudes is 14, 26 minus 14 tells us that the other two segments put together total 12. Because it's an isosceles trapezoid, we have those two segments, this one and this one, are congruent segments, so therefore if they total 12 and they're divided into two equal parts, each part has to be 6. So if we look at a right triangle, this being a right triangle over here, we can say we can use the Pythagorean theorem. 6 squared plus x squared equals 10 squared. So I'll write that down. 6 squared plus x squared equals 10 squared. And we have 36 plus x squared equals 100. We subtract 36 from each side of the equation. And we have x squared equals 64. And therefore x equals the square root of 64, which is 8. And 8 is the length of the altitude. Next problem. Now dealing with the angles of a trapezoid. The angles of a trapezoid, such as angle A and angle D, they're actually same side interior angles formed by parallel lines being intersected by the transversal, the parallel lines being segment AB and segment CD, and the transversal AD. So if they're supplementary, subtracting 180 minus 115, which would give you 65. Angle D is equal to 65. And continuing on the other side of the diagram, using segment BC as the transversal, these two angles, angles B and C, are same side interior angles, so subtracting 180 minus 71 gives us 109, and that's angle B, which answers this particular question. We can continue the problem by saying we have other angles in the diagram. Let's get rid of some of this. And now we can say if we have an angle of 115 here, these two angles are corresponding angles formed by parallel lines because the median is parallel to the two bases. So therefore, these two angles that I have marked off are corresponding angles. So this is 115. And this angle above it is its supplement, which is 65. And on the other side of the diagram, same thing happens. We have a pair of corresponding angles right here. So there's another 71 degree angle, and therefore, likewise, we have another 109 because those two angles right there are a linear pair. So they should add to equal 180. One more problem. Dealing with the angles of a trapezoid, a special case for the angles of a trapezoid is when you have an isosceles trapezoid. If the base angle at the top at point A is 115, A and D are still supplementary, so we subtract 180 minus 115, and we get 65. So that's angle D down here. Then we can continue because an isosceles trapezoid has base angles and points of the same base, that is, have to be the angles have to be congruent. So the base angles at the top are congruent. That's a pair of 115s. And the two base angles at the bottom, angles C and D, have to be congruent. So therefore we have another 65-degree angle over here. Hope all of this helps. Good luck.